agenda. Okay, so share it. Okay, hello everyone. This is our 34th meetup. I think almost 3 years. We did have a break on March 2020. Anyone new here? Just to see if there's any new people joining.
Yeah, this is Rich. I'm new, first time.
Okay, welcome. Thank you for joining. Hopefully you enjoy it. We
Thank
have
you.
kind of a hey Bendine, I heard about you a
Hi,
lot.
I'm Ben.
Hi.
I haven't been to this meetup before.
Ah,
So I
you
thought I'd
have.
come
Okay.
along tonight.
Okay.
I have not.
Good to see you again. So, if you are new, we have so what I'm trying to do here is education. Usually, I have a few weeks every like about 4 weeks to prepare that. But I am soliciting talks from other people. If you have ideas and you want to share it with others on the meetup, by all means, please do approach me and we'll set you up. There's tons of stuff that you can that we can talk about. If you are actively working on C++, that's easy because basically you probably have at least once a day something that you might want to share, either some aha moments or something that you discovered during your work, or maybe something you read online. There's a lot of blogs, there's a lot of things, very interesting. People are sharing a lot of ideas that we could learn. I'm trying to keep it on the beginners intermediate level. I know there's a lot of people that they are trying to either learn C++, maybe get back to C++ after a few years, maybe trying to understand what is modern C++. We are focusing on modern C++ mainly. Um, and um, and basically I'm trying to kind of tailor the whole thing to be accessible, um, not very kind of towards the advanced uh, level, but kind of intermediate or below, so it's easier for people kind of to get into this, and I'm not gonna lose anyone. Well, probably I'm gonna anyway, but hopefully not a lot. So what I have for today is the following. So we'll have Cpp quiz that we usually play with. So I have like a couple of them that I want to have. We have a Stack Overflow question that I would like to share with you. Some new things that introduced in Cpp 20. I want to share with you a book from Jason Turner about object lifetime puzzle. That's just he said that it's going to be a series of books, so this is the first book. Then I have a lead code TDD live demonstration. This is kind of a question mark. I have a problem with my setup. I'll try, if you give me 5 minutes in between, I'll try to fix it. If not, I'll postpone it to the next time. Not a big deal. And one slide from Wallet Fox. I'll explain what Wallet Fox website means. And then I want to kind of give you a quick, I don't know, 30, 40 minutes presentation about the spaceship operator that was introduced in C++ 20, which I think is going to be very helpful for a lot of people that needs to kind of do things related to comparison and similar things. It's going to simplify a lot of your work. Okay, so just one thing to mention. This meetup is sponsored by Qualcomm. When I say sponsored, they actually paying my meetup fee, which is about almost $100 every 6 months. So thank you, Qualcomm. This is a company that I'm working in Qualcomm as part of the WRD software team. It's a wireless research team. So thank you again. We have a Dropbox where I upload my material. We have Slack channel that I'm not using a lot. There is a Discord also, which again, it's pretty dormant, but we have it if you want to use it. I'm usually have my Discord either on my phone or open on my desktop. We have a YouTube channel that I try. Usually that's what happens, unless my kids really upset when I do an upload of 10 minutes and I kill their games. Actually, I have one son that is already gone. He has his own apartment with a better internet connectivity. He's a student in UCSD, so I have only one teenage left to be upset on when I upload stuff. So I try to do it immediately after the meeting or the next day. So I am maintaining the SDCPP meetup handle. My Twitter handle is Kobe_CA, which I tweet about C++, software engineering in general. I also interested in Python. I also looking at Rust, kind of in between. And of course, Linux and similar is also one of the things that I'm interested in. So I would tweet on specifically on these items. I would like to highlight Martin's blog, which I have a sub page in his website, and Martin is here online. So please check out this blog. It has lots of very good stuff to learn from. Okay, so let's start with the Cpp quiz. So what I'm going to do, let me share. We just share the Cpp quiz page. 1 second. And the reason I'm having this quiz is usually I'm trying not to have this crazy quiz that like kind of the corner, but sometimes I do. But I try to have something that we can all learn and maybe common mistakes. And this specific quiz would highlight what exactly we would like to achieve. So here's the first one. Difficulty would be 1 out of 3. Talking about Cpp 17, what is the output of this program? There are a few options here. Either we have a guaranteed output, we have a compilation error, it's unspecified, implementation defined, or it's an undefined behavior. Okay, so take a look. Take a few seconds to look at it. Okay, so we have a class with an integer foo. It is using an in-class initialization. So basically, when I create this instance, the foo member, the integer would be initialized to 0 in this case. We have functions. We have print foo, which just see out of foo. That's if we have an output, that's basically what we would have here. And we have a function, get foo, that returns foo by reference, basically an integer by reference. And the statement here that we have would be out of bar a dot get foo, and then we do plus plus bar. What do we print? Obviously, what this question want to achieve is, are we touching foo inside the instance A, or foo and bar, like the foo internally, or bar, which is outside? There are two different memory locations. They are not. So bar is not referencing to foo. Is it referencing? Is it not? On the surface, it should reference because we are returning int by reference, and this is auto. So what do you think would be the result?
0.
0. Okay, and why?
I think auto is just the deducing the type.
Yes.
Doesn't mean like it doesn't mean it's auto reference. I think
Yes.
it's auto. Yeah.
Yeah, and it is a very common mistake, by the way. I see it a lot, and people really complain that I'm actually want to deduce the exact same type, but it's not. These are not the rules. Like if you read the rules, and the rules are here, it's not really the rules, and it's should be very similar to what template deduction is actually kind of conforming to. So yeah, so this is going to be 0. This is actually makes a copy. It's not auto ref. If you want a ref, you need to specify a ref. Okay, so this was one of them. And 242 would be the next one. Okay, so this would be intermediate difficulties, Cpp 17. Take a moment.
Hey, Kobe.
Yeah.
Yeah, real quick about the auto. There, you can actually there's a decal type auto which follows different type deduction rules. So I think if you change auto to decal type auto in parentheses, it would
this one.
It would actually, yeah, this would actually be the expected behavior because you would then get a reference. Just wanted to throw it in there.
Yeah. So already mentioned that. Let's do it. Okay, so this is what we have. Okay, so do this. Okay, 0. Now, okay, and the next thing I want to do is this one. I believe people already familiar with this CPP Insight. I really like this website because it kind of the X-ray. I call it the X-ray of C++. So you can see how auto being actually deduced to int, and decal type actually. You mean decal type here, right? Actually.
No.
Here.
I mean at the yeah. That's
oh, okay. I have a typo here. 1 second. Okay, so this is the int ref that it was deduced, and if we go back to Godbolt and we run it, it should be 1 here. Okay, thanks, Marty. Okay, let's go back here. So we have a function, a template function that has what we call either universal reference by Scott or a forwarding reference. Okay, and there are rules about forwarding reference, and let's kind of take a look at what's happening here. So F42, and then we have an I, we pass an I. So we have 42 and I. So there are two calls to F, and then we have calls to G. So we have an if that might 1, 2, or 3. First of all, it might also be a compilation error or unspecified. But if, let's say, if it is compiled well and there is no compilation error, we'll have 1, 2, or 3. So we either have an integer or ref or an R value reference deduced. And then stood forward would maintain the same type pass. And then we have an overload on the reference. We have either a ref or an R value ref. And then L or R. And obviously L for L value and R for R value. Okay, so what do you think would be F42? So let's take a look. Let's take one step at a time. It's kind of more on the advanced side, but we can, if you don't know the rules, it might be a bit hard, but we'll mention that. So 42. So 42 by itself is an R value reference. An R value, sorry, it's an R value. You cannot have like a 42 equal to 7, for example. There is no such thing, okay? So from F42, what do you think would be the value, at least on the if side? And it's kind of confusing because I said R value, so people might look at R value, but think about it.
1.
1. Okay, there is a reason why it's 1. I also think it's 1. The thing is, even though I passed an R value, when inside F, right now, the type would look like an int. And there are rules to tell you why it's an int and not int ref or int ref ref. But basically right now it's an int. Now, what happened we do G forward of T? Is it a ref or is it a reference? So basically the forward would be maintaining, like in a very simple kind of simple words, it's gonna maintain the same type. So the type incoming was an R value reference. Was an R value, sorry. So the type would be an R value reference. So it would be R.
Yeah.
Okay. Now we have an integer, which is an L value. So an integer would be, so
3.
the collapsing rule would be ref ref and ref would be ref, right? So that should be 2 if I'm not mistaken. And now we're forwarding that. So I mean, kind of think about it like maintaining the actual type would be the ref. It's not, what I'm saying, it's not like the formal definition, but if I'm not mistaken, it's going to be 1R and 2L. Unless I did a mistake. Okay. So if you read this very long description, 42 is an R value, I is an L value. So with 42, it's an when we inside F, it's an int. Even though it was passed as an R value, it is an int. This is why, by the way, if you remember move constructors, when we have an incoming R value reference into move constructors or something similar, but let's talk about move constructor. We still need to cast it to do std move, which doesn't move anything, just cast it basically, in order to bring it back into the R value reference and do this whole operation of moving. Basically, it's casting and then assigning. Because incoming, it's not. It's just a known R value reference. So that's one of the things that you need to keep in mind. Again, it's not the official terminology, but it's at least it helps me to kind of deal with it. Okay, any question here? This is kind of, if you're not familiar with their collapsing rule and all, it's a bit more on the harder side, but hopefully it helps. Okay. Okay, let's go back to okay. So the next thing I want to share is the object lifetime puzzle by Jason Turner, and it's pretty much a casual, nice kind of a puzzle book for geeks, obviously. All kinds of puzzle. There is an example to kind of showcase what exactly it looks like, and it has chapters, like all kinds of chapters, and you get the idea. Especially if you're new to C++, it really helps you to kind of understand how the whole object lifetime works. There is automatic, there is static, there is dynamically allocated. All of that stuff would be much more clean and clear when you actually solving this puzzle book. Okay, so let's take a look at an example. So what happens here is that, think about, we print when the object create. So there are two arguments that we pass to there are two parameters to each object creation. So one would be the entry, one would be the exit. Like one would be creation, one would be destruction. If there is a destruction, if there is no destruction, we're not gonna do anything. So so if you look at this function, there is a static s object one. So let's say it's the first time it's always the first time, at least until what I solved, always the first time that you enter the function, because the answer might be different if it's the second time and above when we talk about static. But let's say it's the first time. So in this case, we have t. So think about, there is a t here, and then we have an automatic object here. Means it is on the stack. So I, and then we have another static, which is m. So TIM. Now, what happened when we hit these curly braces? So these static objects are not, we're not touching destruction in this case. So we're only looking at this automatic, which is E. So that gives us time. Now, let's say the program is done. So all the static objects are also distracted in reverse order, obviously. So we would have an underscore, because that's reverse order. So underscore and then t. The nice thing, so we have time underscore t. So the nice thing about his puzzles, Jason Turner's puzzle, is that the answer is always something meaningful from either the C++ standard, the C standard, or some terminology from the domain, which is really nice. And the puzzles can be very complex in the sense that there's a lot of nesting and a lot of things that you need to keep track. So it gets more and more complicated in each chapter. So the difficulty goes up. Amazon has it also for $9.99. I'm supporting Jason as a Patreon, so I have it also as an ebook. But I suggest you, if you want to take a look at this book, I suggest the printed one, because you need to write stuff on the book. Yes, that's what I had for this part. Okay, something which I wasn't aware of, and it caught my eyes. I don't remember if it was a tweet from Stackoverflow feed, C++ Stackoverflow, that is. But it caught my eye, and I wasn't aware of that this is actually a C++ 20 change. So take a look at this snippet of code. We have a base class, it has nothing. And then we have a struct derived. Again, class and struct are basically the same. The access specifier is only different. We're using public here as the default, but it's much easier to demonstrate that with a struct, because it's kind of the whole aggregate part kicks in. Okay, so we have a derived from base, and this derived has this integer I. And this person that that is asking this question has also said, I forgot the ampersand, and this not compiling with C++ 17, and it says I'm unable actually to cast. I'm unable to create a derived out of B, basically. No known conversion, and it works well with C++ 20 and above. So just to kind of this always worked, by the way. So I just want to make sure that people. So what happens here? It's the same code, but no static cast. It's just I'm taking a derived, initializing with B. So what happens? And by the way, there is a blog about these kind of things. I don't remember if it was a blog or it was only for Patreon, but Fluent C++ blog had a very nice blog about how you initialize stuff when you have aggregate and you have base and derived and all of that stuff. So I'll try to dig this article and maybe post it later if I remember. But just take a look what CPP Insight is showing. When I have this D and B, I basically have this base B, because derived has base as part of it, and then 0, because if you think about aggregate, everything that I'm not initializing would be zeros. So that's how CPP Insight is showing me this code. So this also always worked. I was pretty sure that I'm just kind of making sure that everyone is aware of that. This didn't work. Okay, so when you try kind of to downcast it from B into derived, this didn't work in 17 and below, but it's like pre-20, but in 20 and above, it is allowed. And I wasn't aware of that until like looking at it. And there is so the answer of this Stack Overflow has the quotes. So derived is an aggregate whose first element is base. If you think about derived, the first element would be base and then the integer. And since C++20, it is permitted to create an aggregate from its first element. And there is the paper that was introduced. Okay. So let's just, before I go into this one, let's talk about WalletFox, and then give me a few minutes. I'm trying to fix I'll try to fix the setup on my machine. Something happened and I'm unable to run something. But before that, let's talk about WalletFox slide. So WalletFox is a website. You can take a look at it here. I have highly praised on their slides, and there is one thing that I recommend everyone would be the ranges. Kind of a guide. It's either an ebook or you can have the kind of a soft copy, which I'm using it a lot when I play with ranges, ranges v3 that is. Highly recommended, by the way, worth any penny if you have a chance to get your hands on this ranges v3 kind of booklet. Okay, so functional programming in C++ 17. Let's talk about stud variant and stud visit. So let's say we have a rectangle and semicircle. They have it's a different struct, and we put it into a variant. So we put it in here. So there is a type def, var shape, stud variant has rectangle and semicircle. Now we have a function that takes this variant type. And again, the variant has two types that it supports. And this area function returns a double. It has this stud visit with the overloaded pattern. I'm not showing it here, but if just browse into CPP reference and take a look how it's being done, there is some hints here. We'll talk about it in a second. But the overloaded basically overloaded, think about it as a callable object. So we have a callable, so visit has a callable object, comma, a variant. And what happened is, in a very kind of a non-official explanation, is the overloaded has, in this case, has two functions. It's basically two lambdas. It's basically, it has two callable functions, two callable objects inside, and one of them would be rectangle, one of them would be semi-circle. We can have actually another one which takes auto as a parameter, and then we can catch other things that, just to make sure, because if we have something that is not supported, we'll get an error, like a compile error, that is. And what happened is that whatever the variant is holding at the moment, if it's holding rectangle, it's going to be dispatched into the rectangle lambda, which is this one. If it's holding the other one, semicircle, it would be dispatched. And this overloaded pattern is basically a struct, a variadic template struct that has this template parameters that we pass being inherited from. So I basically can create a struct, like instantiate a struct, and pass, and when I construct it, I can pass all kinds of lambdas. These lambdas are basically just you can think about it like class, right? They are class objects. So we can inherit from this class object. And what we do, we have this using statement that brings all the operator parens, basically these are the callable functions, into the overloaded struct. So it looks very funky syntax, but because of the three dots. But to think about, I have two callable objects, which I instantiated a struct with, and this callable object basically have this, that actually becomes part of the class. So I have two lambdas or two operator paren inside this overloaded. That's what we ended up with. And there is this deduction guide. Just let's ignore it for a second because sometimes it's confusing. It's just helping to achieve what I just mentioned. And here what we do, we have a vector of this variant. What does it mean? It means that I have this is a very nice way to have a heterogeneous container, because we can have, usually you can't really achieve it easily unless you have like a base class and you have pointer to you have pointer of the base class kept in this vector, and you have this derived. This is much cleaner in terms of what we want to express. We have a rectangle and semicircle and semicircle. So we have definitely heterogeneous. Just pay attention there. This rectangle and semicircle, they are unrelated types. They have no common base class, which is very interesting because if you're coming from old C++, there are much more, I would say, primitive ways to achieve the same. Here it's kind of more sophisticated to achieve this heterogeneous way of putting stuff in the container. Now we have this stud accumulated, which is part of numeric header, and we pass begin and end. So remember, accumulate has range. So begin and end, we have an initial value, which would be 0.0, basically a double. And then if you know what is the requirements from accumulate, the callable object that it expects on the fourth parameter has two parameters. One is the sum so far. Let's say that what we accumulated so far, and accumulated is kind of an abstraction. It can be anything. The default is just to do sum, but you can do anything. So you have double, and then you have the next element of the vector because we iterate over the vector. And if you remember, the vector is just a variant. So we pass whatever, so index 0, whatever index 0 has. Then we do D plus area S, and area S just return double, right? So we keep computing we just keep accumulating, and every time we pass the next element, we call area. And if you remember, area is just accepting this stud variant because this is just a type def this using. And then it's being dispatched to either rectangle or semicircle, and it provides me, so like unrelated classes, unrelated lambda, and we get an unrelated kind of computation, but it's all very nicely done on the very high level. When you look at accumulate, you don't really care about how it's being accumulated. Like two different formulas, but it's being handled internally, like the whole dispatch, and it's pretty clean. I really like this approach, much better than what we had like a long time ago before Cpp 17 introduced variant. Obviously, if you used boost and similar, you already had that even before Cpp 17. Any question related to this?
I have a couple of observations.
I'm sorry. Yeah, just a quick question. Can you explain that second template class that is overloaded?
This one?
Yeah, in the second gray box, the last line.
The last line. Template.
That is still a mystery to me.
Template type deduction. Basically, what it says here is when I create, like again, then it's not an official explanation. Like it's how I kind of explaining to myself. When I see this overload, and this is the overloaded, right? And when I see this overload, I'm actually going to instantiate this template. It's a template class, right? Or template struct in this case. I'm going to instantiate it as if I had this overload of these types. In this case, there are two types, two lambdas. It's a template type deduction, if I'm not mistaken about the terminology of that. And without this one, there's going to be an error. This actually helps, and there are the standard library that is shipped with similar construct. They also, you can take a look at some of them. They have type deduction guide type template type guide deduction. I don't know if that's the right terminology. I'm kind of flipping words, but basically that's what it's being done, because it is. Take a look at it here. Overloaded is basically a template. It's a struct template, but I'm not actually specifying anything. So how do we deduce the TS1, the TS2, the TS3? Like there is no like angle brackets. So basically that's how, the way I see it. Again, it's not the official explanation from the standard. You need to look at and read the standard. But this is basically, so, okay, overloaded of TS, when I pass this when I instantiate and pass this parameter, it's going to be instantiating this overloaded as if I was. Now, if you think about it, it's going to be very hard, not hard. It's obviously possible, but very verbose to say overloaded of decal type of this lambda and decal type of that lambda. It's not needed with the type deduction, the guide deduction.
Yeah,
the term to Google is class template argument deduction, or CTAD.
CTAD, yeah.
CTAD.
Yeah. Thank you.
In the gray box, in the first gray box, the line overloaded curly brace makes sense. You're basically constructing it, the type, this struct overloaded, and you have a constructor there that takes multiple lambdas. And so the types, right, in Cpp 17, I think, the template types were able to be deduced from constructor parameters, which wasn't the case prior. You would have to have the angle brackets there, but you no longer do. So that I get. Like in the gray box, the second gray box, that first line, struct overloaded, colon TS, that I get. That defines a class template and class struct template, and it just inherits from whatever, the multiple different types. Lambdas, yeah. And then using TS colon operator,
just bring it in.
Sense. Yeah. You're bringing in into your scope, your name scope, the operators from your classes that you're inheriting from. But that last line, I have no idea what it does. Does it define a constructor? Does it define? Is there something about templates I'm missing that it tells the compiler what?
So you,
Like
I think you're asking why, like, for example, stud
That's
vector.
just the syntax for the deduction guide introduced in 17.
Okay, so there is something new about templates in the core language in 17.
That is new for 17. That's a template deduction guide, and that's just the syntax for it.
I see. Okay, so you can hint. I guess it's about hinting to the compiler how to look at the code and figure out what types it's dealing with.
So Martin, if you ask, are you asking, for example, if I have stud vector and I initialize it with 1, 2, 3, 4, so it's stud vector of int, but I don't need in 17. I don't need to say stud vector of int. I can just do stud vector,
Right.
which is kind of confusing people. But I can do have same for stud lock and like all the stud locks have, that have like, let's say you don't need to say stud mutex because you initialize with the mutex. So they might have CTAD already baked into shipped with the library, like for this specific class. Like if we can take a look at how stud vector, if it has CTAD, and it might have, and this is why we are allowed to do.
Okay.
Yeah,
vector.
it does.
I
does, okay.
think I now get what that last line in second box says. It basically says, hey, when you see an overloaded constructor, I suppose, called with a sequence of types, that arrow pointing to the right tells it that that's actually this class template instantiated with that sequence of types.
Yeah.
Okay. Yeah, thank you. No, I wasn't aware of that was introduced in 17, this type deduction hinting. So
Okay.
that's very important.
Yeah, it's I'm kind of on the fence about when to use, actually as a user, not as the author of a specific function, but as a user, when would I kind of use angle bracket and say, okay, stud vector of int 1, 2, 3, 4. Either if I do an example or not. I'm kind of on the fence because for newcomers it's kind of confusing because it looks like a non-template class or non-template start, and I feel like it's sometimes like I understand because I know that stud vector is a template, so I know that if like I know the rules. I know I'm 17, so I know this is allowed, but I'm kind of on the fence sometimes about should I use it all the time or not. I don't know how other people feel and how how people are using it in their daily job and their C++ code.
Probably the most useful thing about it is for stud array, because the other thing about it is that you can't deduce like some template arguments and not others. You can't write a deduction guide like that. So array has both the type and the size as template parameters, right? And so it's annoying and error prone to have to write the size when you're providing like the array literal, as it were, to initialize the thing.
Right.
So it's really useful for arrays.
Okay, it's a good point. Actually, I haven't thought about arrays because array is an interesting part. So
Also declaring the value, a variable of type std array, you no longer need to give it the integer, right? The first parameters size.
Exactly.
it's a good point.
Yeah, it deduces it from the array because
I haven't thought about array. Because this is really, I agree, it's annoying.
What is this mechanism called again that
That
we were discussing about this template deduction hints?
let's say and what is being seen by the X-ray That's the way I see it. It's X-ray. Yeah. Thanks.
Sorry.
This is actually I actually haven't thought about array because I really hate writing the number. I usually have a const expr for the number, but it's like, why would I do that? Like, and I think what I usually do, because I hate writing the number, I haven't thought that stood array with CTAD, so thank you for that. What I usually end up is doing something like, I think there is something like this. Is it like that one, or is it, do I need the curly braces? I can't remember. And this would be, I think this was introduced in 20, if I'm not mistaken. So that's another way. Both of them are valid. Both of them are going to be the same, but I'm definitely going to keep that in mind when I write std array, because I really dislike the fact that I need to repeat this, and it is error prone.
ToArray is useful because sometimes you want to. CTAD can't deduce only one thing, so you can't say I have a std array of int and then CTAD deduce the length, and that's where you want ToArray, because sometimes, you know, like all the literals you put there, you want to say these are actually chars or unsigned uint 16s or something, you know, something that's not easy to write as a literal, but you know what type it is, but you just want to put it would be deduced as an integer, except you want to make them say uint 16s. And in that case, you can use ToArray, and you can say these are uint 16s, but the compiler still deduces the length.
I see. So you're saying here, so ToArray is basically.
So you can give a template argument to ToArray. You can tell it these are really, you know,
Let's
unsigned
say
ints
I
or
want to
whatever.
make it a uint, let's say 8, for example.
Yes.
So let's okay, got it. Okay. Yeah.
So
that's a
you
good
couldn't
point.
do that with line
Yeah.
6 there, because you
Yeah.
can't. Yeah, you can.
Yeah. Awesome. It's a good tip about using ToArray. Another motivation. By the way,
Hey,
this.
Kobe, I have a
Yeah.
small question about that. So I tried to use CTAG with std array, but my array, I tried to do it const expression, and it didn't really work. Like it didn't want to compile in 17. I wonder why.
Which compiler do you use, Gil?
Clang 7.
7. If you have a chance to post it, either before the end of the meeting or maybe through Discord, let's take a look at that. Worst case, if you can't do it through Discord, or we can definitely look at it next time. And did you? Okay, and then we can try it on Godbolt and with this compiler. So
Sounds good. Thanks.
one of the things that I'm kind of diverging for a second, but it's kind of a fun discussion. One of the things that this discussion reminded me, I think something that Bentin just mentioned. What do you think about this? It's already have this red line. So it's okay. What people think about this one versus this one?
It's a byte too short.
It's too short, yeah. But Y in C is fine. So it's not defined. I think, is it undefined in C++? If we don't have the null terminated, because what happened is that in C, it is as if you had H and then E and so on and so forth, all the way. Okay, that's it, right? So it is defined. Okay, it's not null terminated, but it is defined. In C++, it's not defined. You you must have this because hello is basically has this at the end, and it's too long. It's fixed like this. Obviously, no one writes, right? No one writes like this. This is enough. Let the compiler do the work for us. But that's this whole discussion about arrays, just because I've seen that, I think, on Reddit this week. Someone was asking about it. I can't remember if it was Reddit or something else, but someone was actually asking about like why it's different between C and C++. But there is a difference. I can't remember the reason for that though. Okay. So what I'm going to do now.
I just wanted to say, Kobe, before you move on, I looked up toArray on CP reference, and the other use case it gives is passing a string literal in. So if you say std array, and inside the curlies you give it a string literal, what you've created is an array of const char star of size 1, right?
Oh, when you say std array of.
If you say hello there, that gives you an array of 6 characters.
Nice.
So that might be useful.
Yeah, it is useful. Yeah, thank you. Okay, that's already a useful 15 minutes for me, because I always wanted to get some more motivation about toArray, but then we have it. I think the first time I actually noticed that this new addition was in what's his name? Like he's from the Bay Area. He's from the committee, and I kind of forgot the name right now. It will come to me. So he explained about why do we need std array since we have toArray, and the bottom line was that std array still gives you, like, versus just C plain arrays. Std array gives you this value semantics. You can like move, not move, but move is not the right word, but you can. It has a copy semantic, right? It's like you can pass the whole array. It's not decaying to pointers, right? So that's one of the things that, and I forgot his name. He's a very famous person.
Is it Bryce?
Not Bryce.
Not
He
Bryce.
is he's I think he's running, like he has a lot of yeah, he has one book. I forgot the name. It's kind of embarrassing. But anyway, it would come to me in the next
We're
half an
not
hour.
talking about Alexander Shoe, are you?
No. He had, one second. He had this const expert. His last blog was about const expert. You can query if a specific expression is a const expert.
You're talking about Arthur O'Dwyer.
Arthur O'Dwyer. So thank you so much. Yeah, so there is a very good blog, maybe a year ago or something like that, or 2 years ago, about the motivation of still using std array now that we have toArray. And this is actually the first time that I actually realized that there is a toArray, and there's some takeaway from this specific blog. So I kind of recommend. And by the way, he has a very good book that was published on Packet. I don't know how to pronounce. Okay, and Packet. So he has a very good book that I think at least maybe 2-3 years ago, this one, mastering the C++ STL, C++ 17 STL. I read it cover to cover. I think it's good. It's not an easy book. Like, I would definitely read it again and again to absorb more and more. One of the things, and I had a whole discussion with him in CPP Con with Arto on CPP Con 2019, just before the whole thing started. And I really liked your book, but you actually always pointing to the dark corners and what is wrong. I said, yeah, I like to point out on the on the issues of all kinds of stuff. It's a very good book, by the way. So you can take a look at the index. It has a lot of very, very interesting stuff. Not an easy book. I do remember that file system, like the takeaway, at least back then, that file system is pretty much busted at that time. But just yeah, if you have a chance to grab that book, so please do. Okay, thank you for reminding me. I've sometimes blackouts on names.
I wanted to. I just had a couple of things to critique on that WalletFox page. If you can bring that one back up.
Which one? Which one?
The one from WalletFox.
Oh, the slide.
The slide, yeah.
Okay,
Yeah.
1 second.
Or a couple of things to point
Yes,
out
yes.
that might be interesting to folks. A real trivial thing here is this uses MPy, which is a macro, but in 20 we got the numbers header. So we have stud : numbers : pi now, which is a variable template.
Yeah,
No longer a macro.
yeah, this one.
That's kind of a trivial thing. I would say, and the other thing I would say about this is that it uses std accumulate. I think a better choice is transform reduce, because area is the transform function and std plus is the reduction.
Nice.
And
yeah,
but moreover, the advantage of using std, so std accumulate is very versatile, but it's one of the only functions in the algorithms or numeric header in the standard algorithms, I could say. It's defined to work strictly left to right, so it cannot be parallelized for that reason. Whereas transform reduce does have parallel overloads. You can just drop them in.
And this specific use case is ideal for if you have a huge amount. It's pretty
Sure.
useful.
Yeah, I mean, for a vector of 3 things, this is a toy example.
Yeah.
But in general.
In general, it is, because not everything, like there are some it needs to be either, I can remember, I used to remember that from Connor Orchestra, because he's always looking at it, like the operator need to be either transitive or I can't remember there are some conditions that needs to.
Mathematically, reduce requires only associativity, but in C++, std reduce and that family also requires commutativity.
Commutativity, yeah. Yes, right. Thank you. Yeah, that's very useful. So I think what I'm going to do right now, since we are already in 6 p.m., is I'm going to jump to the overload, the spaceship operator, sorry. So give me a sec. Hopefully you don't hear my teenage son screaming. He's playing a game. I think he's done homework for today. So
no, you're all good. Can't hear him.
I'm all good. Yeah, the noise cancellation proved itself. This is actually a gaming headset. I used to do a lot of gaming like 15 years ago, until my daughter was born, like almost 11 years ago, and then I stopped gaming, and I started doing more C++, which it's not as fun as gaming. But we have Spaceship now, so it might be as fun as gaming now, because it's more fun. So there are not a lot of, like, if you look at C++ 20, I am sharing, right? Do you see that? Okay, hopefully you see the first slide. So there's usually in each standard that is published, there's variety of stuff, and by the way, there is a book that was published recently, Embracing Modern C++ Safely. Uh, John Lakos and Vittorio and two more. I just know that these two from the top of my head, but there are four authors. It's a very thick book about what is safe to use in terms of features, what is kind of in between, and what is not very safe to use. I highly recommend. I didn't read the whole thing, obviously, but I flipped through the book, and it's something that is worth looking at. So in every standard, there is a variety of stuff that we can use. But some of the things, the way I see, and it depends on the standard, the way I see, I can divide it to at least roughly two categories. One is a category that everyone can use. It's for the public usage and all. And there is the more sophisticated stuff that I think is more targeting. This is my opinion, by the way. It's more targeting the library authors. It simplified their job. I know, for example, C++ 20 simplified a lot of template metaprogramming and things like that. Obviously, with concept and so on and so forth, it makes things easier for people. But it's not really something that I would see the average C++ developer reaching out and using. So so they're basically like kind of two categories. In C++20, obviously it's the same. And one of the things that I think would benefit a lot of people would be the spaceship operator. And I kind of remember Herb Sutter talking about the spaceship operator like long time before it's actually got into C++20. So I do remember, I don't know if it was Cpp Con 2016, which I attended. I attended, I think, couple Cpp Con. One was 16, one was 19, and I had at least one Cpp and beyond, and then SD West, couple SD West in 2005 and 6, I think, or 6 and 7. So I remember like Herb Sutter had this vision about let's have this spaceship operator, and I didn't really got the whole, like, if I didn't grasp the full potential and motivation behind that. It is something that I think would be useful for a lot of people that need to reach out to any comparison operator, which means either equal, less than equal, and all of that. There are 6 of them. So I think each of us as a C++ developer needed to do it at least once, and it's gonna, if you hopefully by the end of this presentation it's gonna be useful. Now it's very important. C++20, the complete guide by Nikolai, has, I think, the first chapter actually talking about the spaceship operator. So it is this important, this, I would say, basic, if this is the first chapter, if I'm not mistaken. Okay, let's jump right into it. By the way, I would upload the slides. Each slide, if you look at the notes of each slide, there is a link to Godbolt. So if you want to play with something, you don't need to type. I made sure that there is a link to Godbolt for each of the, at least most of them, if not all. Okay, I am int. I have an integer. I just initialize it to 0 by default. It's not really matter for this case. I just kind of used to initialize stuff. So I have 2 integers. So 2 class that wraps integers, I1 and I2. And I would just want to return I1 equal I2. It just, the return doesn't important. The important part is that I'm trying to have an equal operator on these two instances. And I have this, obviously it's not going to work. if you know the rules, the compiler is not generating anything like this for us. It's not a special function. It's not like an assignment operator or some specific constructor or destructor that compiler is generating for us. This is outside of the compiler scope. It's not doing that. So you need to do that. And fortunately, C++ is allowing you to add this, like to overload this operator. There's like millions of gazillions of operators that you can overload. This is one of them. Okay, so what I'm doing here, I'm everything is public just for the sake of having things short and brevity. So I'm returning bool. So the signature will be bool. If you're new to C++, it looks very funky, but this operator is a function. Everything in C++ is a function. So be aware of that. Not everything, I'm kidding, but everything can be a function. I can overload a lot of things. Then you have, I'm passing just a const reference. I'm marking that as a const no except. It is a const function, no except, because I know that this is not going to throw. I'm just marking it as a no exception. There's no exception happening here. And then I'm returning I equal im int dot I. Now everything works. Why? Because I teaching the compiler how to do assignment with this specific instance. Okay, but this was the old days, pre-20. Before we actually delving even into the spaceship operator, and spaceship operator, basically it's the angle, and then equal, and then another angle bracket, not the bracket, but angle, whatever angle. And in C++20, you can have the same thing if you don't need to do anything, and it's just an integer. You can have you can mark it as default. This is starting for C++20. You don't need to do anything special. The compiler would do this for us by just marking it as default. This was actually one of the things that I didn't realize when I first looked at this new feature. I didn't realize that we actually have this equal default that is already useful even before actually accessing any of the spaceship operator, and this would work. Just make sure that the return value is bool. Don't mix it with anything else. Okay, here's the nice thing about this feature. I'm actually getting not equal for free. I don't need to do anything else, but not the other way around. Like this is actually a typo. Now I'm seeing a typo in this here. It needs to be equal. So basically, if I have this not equal, I'm not sorry. If I have the default of equal not equal, I'm not getting the equal for free, which is basically being used by the compiler in order to have not equal. So the compiler is actually doing kind of a rewrite. If I have equal, the compiler would do a rewrite of basically adding another operator which is not equal, but not the other way around. Okay, so there is no match. There is no match for operator equal. Just because I have the equal default doesn't mean that I have the equal. So it doesn't work this way. So just remember that this works well. It gives you both equal and not equal. The other way around doesn't work. Okay. Okay. So we have that fixed. We have that done. We have equal. We can do equal default. But what about other things? if I try to have the same, if I want to have I1 less than I2, if I try to do that, again, I have the same error. Now, if you think about, hey, why do I need to do that? If you're trying to sort, and I bet any C++ developer tried either to sort or compare objects, right? And the object, they have maybe one or more members, and the comparison is, let's say the less than is related to a specific, maybe all members or maybe one member. There's this trick with using tie if you want to have few members. But I bet if you have stud sort of classes or struct, you stud sort by default has stud less. But stud less is basically a wrapper that calls operator less than. So if you don't have it, you're gonna get an error. It's a very nasty error, by the way. There's a lot of lines and all. So when we try to do this, it says you have no match for this operator. It's missing. So if I extrapolate it to everything else that we know, it's a very trivial, though very tedious job to do. You need to define all these 6 members, and there is a rewrite. So some of them would call an existing function, but they still need to write it. The compiler would reverse. It would rewrite some stuff, but the problem is that I need to write all of that stuff. Now, things got even worse if I want to have an operator. Think about this example. This one, for example. So if I want to have an operator equal that takes an int, I need to do the same thing. I need to go and write it. So it becomes a very, very expensive in terms of maintenance, lots of code is liability, and so on and so forth.
Hey,
So there is a lot of
why to write no except here?
Sorry?
Why do I need to write no except here?
If the no except is good, okay, I'll say the following. If the no except kind of confusing, so I tried with and without no except. It didn't make any difference. I can remember top of my head what the standard says if I do add the no except or I remove it. I think it needs to be const, if I'm not mistaken. But the no except here is kind of optional in my opinion. Just ignore it if it's confusing. Yeah, unless you're asking what no except is doing in general. Is that what you're asking? What no except is doing in general?
Yeah, I mean, I have basic sense in general, but yeah, if you would like to explain why it's a best practice or something.
Okay. Here's the thing. It's best practice kinda. There is an issue with no except. I'm very aware of that. Okay, let me tell you that. No except tells the compiler, look, I am guaranteeing that there is no exception is going to be emitted from the function. Okay, so I'm guaranteeing that. Now, the compiler would take a look and see, am I speaking truth, and how the compiler would do that? Let's say it's either I do something which is really no except, like equal, or I call functions that they are marked as no except. Now, what happens if I call a function? So I'm inside a no except function, and I'm calling another function which is not marked as no except. And there is an issue with C functions because they're not marked as no except. And there might be a paper that fixing it. I can remember that. But there is a person that I'm following, Hannah, if I'm not mistaken, her name, and she had a long time ago. She had like a macro that wraps these C functions and make them a no except, and you can call it. It's really cool. But anyway, if you're inside a function that is marked a no except, and you call something that is not marked, the compiler needs to make sure that this is not there is no exception emitted. So it needs to add code. So you actually, maybe we make because it is important, and I want to give you a quick, hopefully it's going to be quick, but it's kind of a small diversion, but we're here to learn, so it's going to use it. Okay. I'll try to kind of kind of demonstrate it. Hopefully everything is going to like the whole thing would cooperate with me. Okay, so let's say I have a function that is marked as no except. And I call this function. Okay. All good. There is nothing. I don't see anything. Let's turn optimization on. Okay. So okay, now I don't know if it's gonna work well, but let's not just run the functions. We don't want to execute. Let's say I have another function is not marked as, and I'm not even implementing it, not defining it as a function. Now, as far as I remember, it's been a while. I would expect here that there was going to be some more code added in order to, maybe it's too, okay, let me do this. Okay, so let me take a look in a second. So it's throwing, and I was just expecting that in Func, we would have some code making sure that, okay, let's do this. And let's call Func. Yeah, it doesn't really. What I was hoping to see is that Func is actually guarding against throwing a function, throwing an exception. But I don't. Maybe it's too easy for the compiler to see what's going on. I don't know. Yeah. I used to, there was one time that I managed kind of to, there is an article, or I need to dig it from my bookmarks. Someone made some observation about the code generated when you have no except, and it's not like all the call chain is no except. Some of that is actually missing. So what happened is that more code is generated. Yes.
Try maybe declaring function G first and then defining it past main.
Okay.
Maybe that will work.
Okay.
It's a guess, but or maybe define it extern. Yeah, but as long as it's defined past function.
Yeah.
Func, right?
Yeah, I need to look again. There is something. There is an article that I remember that mention how no except. But basically, the idea is that
try disabling optimizations too.
yeah, I thought about maybe disabling optimization because then maybe Func would be okay. So G is turning Func. Yeah, I don't see any specific code from Func making sure that G is. But if we let's say just remove G. No, now I need to take a look at that. But basically, what I was about to say is that, yeah, it's good practice. What I'm trying to do is kind of be aware when I write code that the no except is, at least on the leaves of the call chain, is if it's no except, I put no except, so other function can benefit, other no except function can benefit that calls that. But it might be kind of a double-edged sword in some sense that, oh, I was like, I really wanted
Kobe?
something. Yes.
I'm sorry. Can you add a separate file to this compiler explorer?
Okay.
A separate compilation file. Maybe if you mark void g as extern,
Let me
and
see.
then move it over to another compilation. Then at that point, when compiling the first file, the compiler has got no idea what G actually does, right?
So maybe I can't remember how to add the new file.
I mean, I think we're seeing the compilation. The existence of the other file doesn't matter at the moment. G is only declared, not defined, so we got exactly
Yes.
the same.
Yeah. Yeah. I don't know. I'm gonna do something stupid. 1 second. No, I didn't. Okay. I'll get the example done, and
Copy.
yes.
One difference with no except is that the exception is not forwarded upstream. So if a function is no except and there is an exception in the function, terminate is called immediately. So if you in your main you put a try catch, it won't be triggered.
Oh, I mean, if I put try catch calling to func, right? Because
If you put a try catch in main,
try catch
calling
in
func, calling f, then the try catch in main won't capture the
won't trigger. Yeah. Let's try it. Okay, it's a good point. Let's do this. And just return 42. Let's run it. Execute the code. It's optimization disabled, but yes, it's terminated. Now, otherwise, if it wasn't, and it was like G, okay, there was no exception, so 0, this is not happening, but yeah, so thank you. So this is what I was just expecting. Maybe my filters are busted, right? Oh no, because I was expecting to see this whole code that actually call terminate somewhere here, but this is actually a proof that there is a terminate somewhere hidden. I just can't remember. Maybe different compiler would do it. Where is my Clang? Here it is. Let's talk about it. Oh, okay. This is actually much better. I don't know how. But okay, this is what I was, and that's just to throw one. This is what I was expecting. Let's turn even optimization and see if it makes things a bit more condensed. But okay, so here's what I was expecting. This code. I don't know why GCC is not doing that. Obviously, there is a terminate called. If anyone knows why the difference between the two generated code, but just to answer the original question, it is best practice, but take a look what happened to F. Sorry, to func. It's because it's no except, and if I had no except here, all good, because what happened is that func is calling a no except, and no except is doing nothing, so it's guaranteed not to throw. So there is no code that needs, like, there is a guarantee that nothing needs to be guarded because of this guarantee. So yeah, the thing is, in a huge code base, you need to be aware of exactly what's happening and how you structuring your code. So double-edged sword is the only thing that I can think of. Going back to the spaceship stuff, I tried to do both with no except and just to play with it, and I didn't see any issues in terms of like compiler errors or anything like this. I didn't see any issues with having no except or not having no except. Okay, let's continue because I want to complete before the time is up. Okay, so let's talk about. Let me see that I completed that. Okay, so I mentioned the whole reverse and rewrite. So reverse, basically, you can have 3 equal to object is also deduced from the operator equal to int. So the compiler can actually reverse and rewrite functions for us, which is a huge advantage in C++ 20. Okay, so not like equal and not equal are for equality. And we also need to be able to order things not only by equal and not equal, by also less than equal, greater and greater than equal also. So there are other stuff. Oh, this is where equality versus equivalence comes to play. There is one 6 minutes that I want to pitch to you that helped me like many years ago. So there is a one YouTube that I always keep going back to this YouTube and recommending. It's a 6 minutes 42 that explains very nice what the difference between equivalence and equality. Now, if you want to just hear the non-official simple thing, the way I see it, again, it's not the official one. Equality is like, I would see it as a like bitwise equality. Again, I don't know if it's the right official thing, like 7 is equal to 7. Equivalence is something else, like the values they are not necessarily the same, but there is some other trait that says, okay, they are equivalent. Think about if you want to maybe sort something in like in kind of a lexicographical like strings, but case sensitive versus non-case sensitive. You can have the equal operator just not dealing with case, and then they're not like having hello all capital and hello or lowercase. They're not equal, right? They're different characters, but they're equivalent because we have this trait of we don't care about the case. So this is like one way to look at it. But if you look at this, if you watch this video, it's pretty nice. It's explaining how it can be used in let's say sorting and putting stuff in map, using not equality but equivalence. Okay, so let's jump to what C++ provide. So C++ provides this new operator. Note this auto thing, we'll talk about it. I needed to include compare, and compare basically has this constant that I'll show in a moment that are needed in order to have this operator, at least the return value, kind of known. So the moment I have this operator, I have all the 6 operators defined. I don't need to do anything else, and this would work. And by the way, I kind of removed the no except just to show you that this is not doesn't have to be a no except. Just note the auto return value, which is the important part. Okay, so what exactly happening? And if you again use CPP Insight to understand how this whole thing, what this whole thing is all about, and the important part that I want you to kind of note, there's a lot of things happening here. First of all, we have this operator equal that is added for us, and the spaceship operator is also there. And this stood strong ordering is deduced from auto. Now, we'll talk about the ordering in a second, but this is where I mentioned there's some constant that we need to at least be aware of. And why strong ordering, I'll tell you in a second. Another thing that is important that as I mentioned, that the operator equal is essential, and it's being added to our class, like the compiler is adding it for us. Now, there are few ordering. What is being deduced depends on the members of your class. Integer, we can have strong ordering, right? We can have less, we can have equal, we can have greater. If we didn't have, if we had something that only defined weak ordering, like let's say the integer was not strong or it was weak, auto would be deduced to the weak. Even if I have an integer and another one was weak, it would be deduced to weak. Because strong is basically can be downgraded to weak, and weak can be downgraded to partial. And this is taken from Andres Ferdig, excellent book that I already mentioned before a few times. It's a very good table. So there are three categories. There is a strong, there is a weak, and there is partial. Now, equal is only available in strong ordering. Okay, there is no equal in weak ordering. There's no equal in partial ordering. Okay, partial ordering means that not everything can be ordered. This is why they have this unordered. So think about it this like enums. They are constant, but think about it like enums. Okay, and as I mentioned in this bullet, this operator has return value that can be expressed as -1, 0, and +1. It kind of reminded me the compare functions. If you think about str compare and similar, you have 0, +1, -1. So if you look at CPP reference, it has all the information about each and every, and they are, as I mentioned, they are defined in compare. This is why I needed to include compare. And as I mentioned, the strong ordering is the only one that has equal. The weak ordering is the only one. Sorry, weak ordering has less equivalent and greater. It doesn't have equal. The partial is the only one that has unordered. And one of the, if you look at online and say, okay, why do I need partial ordering? Where is partial ordering? The most common example that everyone is using is floating point with none. None is not comparable with any number. So, and another one that I found is 0, 0 and -0 floats. No order in between the two, so it's unordered. Have fun with that. Okay, so this is nice and very useful, but the question is, how can I use it in my own classes? If the default, the member-wise comparison is not enough, you can write your own implementation. So you can have, if you have pointers and you want to compare them, and it's obviously if you put the spaceship operator, it's going to compare the pointers and not what we're pointing to. So obviously it's not the right thing. So that's like the most common example if you look online of why do I need to implement my own. So that's one of the common examples, but not only. So let's take a look at one way to implement, one use case to implement your own spaceship operator, case insensitive string comparison. So as I mentioned, they are not equal, the equivalent. So I'm already kind of defining a compare function. So I'm defining my own compare function. The implementation is really not really important. The important part is the return value. Okay. So we have a weak ordering because again, we have equivalence but not equality. And then we either have less, greater, or equivalent. And the algorithm of doing that is pretty straightforward. That I do here to lower, but it's not really. I didn't even test it if that's working. I just came up with the implementation and just put it as an example. But the idea is pretty simple. We are checking two strings for equivalence, and we are ignoring case. It's case insensitive comparison. So what do? We have a std string, and we can have all kinds of iterator and all. That's something else. But take a look what we have here. So we have a constructor that takes car pointers. So because I'm using literals, string literals in the next slide. But you can have anything else that you can, like std string gets a string literal and all good. One thing that I'm doing is I'm defining an operator, like spaceship operator, like three-way operator, and its parameter is const by ref of store example, and it's calling icomp. By the way, icomp is not marked as no except, which is my bad because this is no except here. Okay, it returns auto, and by definition, because I'm actually using icomp, it's going to be deduced as weak. Okay, because icomp is returning weak ordering, so auto will be deduced as weak ordering. Even though string, by the way, string is strong ordering as far as I remember, but I define my own three-way operator, like spaceship operator in icomp, like in case in non-case sensitive would be the one that is being used here. So obviously it's going to be weak. The other thing that I need to add is this operator. And this equivalent, sorry about the typo, equivalent is convertible to 0. So I can actually compare it to 0. And there is a Stack Overflow in the notes. What does it mean compared to 0 and how does it work? So I'm not showing it here, but you can actually compare it to 0 and be done with it. Just note that I'm using bool here. And basically that's it. So without this equal, I cannot have this. This one needs an implementation of equal. And it would return 1 as expected because they are equal in this case, but they are also equivalent. Now, this one returns 0 because they are equivalent. It needs, right? S1 is not less than S2. They're actually the same. So I have hello and all capital is hello. This one returns 1. Even though they are not equal, they are definitely equivalent. And since they are equivalent, this is how we implemented icomp. This in case like a case insensitive compare. This would be returning 1. Again, S1 is not less than S2. They're actually equivalent. They're not. So it is returning. It will return 0 if, let's say, it's inside main. What else can I do with customizing my spaceship operator? There are other things that we can do. Let's assume that I have this struct integer. It's basically very similar, and I have this array of five instances of this struct. It's an aggregate, so I initialize it with curly braces, all good, and I'm sorting it. Okay, so by default, sort is stdless. And if I had an operator, so obviously if I don't have an operator, any operator, it's going to be an error because there is no std there's no operator less than defined in int. But if I have a default of three-way, it's going to be ascending order. If I want it to be the other way around, I can actually define an operator. And take a look what I did here. I'm using this spaceship operator here with auto as a return value. It's going to be strong. And what I'm doing here, instead of doing my member, this member, and then the three-way, the incoming parameter, I'm actually reversing them. This is a nice trick that I've seen online, and this is how 7, 5, 4, 3, and 2 would be printed. And this is basically as if I would pass stud greater, and I would have stud greater to the sort, and I would have a greater than operator that actually implementing this I is greater than the incoming one. So this is a nice trick that you can do. So basically, you can customize your spaceship operator on your class any way you want in order to put some semantic that you want to have to some ordering related to your class type or struct type.
If you made that a template, so the int would it I guess you'd have to have something to terminate the, like, int would be now type T.
Okay.
Right. Then you could do it for int, float, double, all those things.
Oh yeah,
but,
yeah.
That won't overload the original operator spaceship, or.
So if I have, so every instance that I create would create a new struct with this specific. So if I have an instance, of int of ints, so I have so the compiler would, it's as if I wrote this class. If I have double, so double would be unordered, if I'm not mistaken.
I guess I don't. I mean, since I haven't used it, I don't know. But I mean, it seems like it's candidate for a template. That's I guess.
Oh yeah. Of
that's
course.
all I was trying to say.
Yeah. It's
yeah.
If you yeah, this is just an example, but definitely people would end up having it, and it's not going to be an int. It's going to be, I don't know, number or something like that.
Yeah.
Okay. The nice thing about this operator is that you don't only have the opportunity to define or default operators or define operators, and you also have the option to disable operator, which is really important, because let's say you have a specific semantic that a specific operator doesn't make sense for some reason. It is possible to do delete on this operator, just like we have delete from C++ 11. So we have the same here. So this would fail. This would not work. One thing about const expr, you can have const expr of the spaceship operator. You can have const expr of this spaceship equal default. If can be evaluated in const expr context, it would be in const expr context. So that's also good. The stud library, the standard library has support in the spaceship operator in strings. Pair might be more. Strings has strong ordering, pair has partial ordering, but there might be more, but it's just two that I noticed. Okay, so this is basically my last slide. So I just wanted to acknowledge great resource, Program with C++20. It has a chapter on the spaceship. Here's the spaceship operator here. Very good book, by the way. There was a Reddit discussion. Actually, started from a LinkedIn, and then there was a Reddit, and I think there was also a Stackoverflow that someone added. I might be confusing with another Stackoverflow, but someone from LinkedIn said, okay, C++20 is breaking something, and I want to show that we have 2 minutes. I want to show that this is something that kind of a concern, but
before we end on that, Kobe, could you quickly show your string example?
The icomp or
the icomp? Yeah, the icomp.
Yeah.
Or maybe it's the next slide.
This one?
Yeah, the slide where you said So I don't believe equality is required. If you define spaceship, equality will be
it was
synthesized.
required, yeah, for this one to work, because I'm using this one.
Okay, but in general, if you define spaceship, you get the compiler can synthesize equality.
Yeah. Okay, let me because I prepared this slide like a long time, like a few weeks ago.
The other thing to note here is that there's an algorithm that's new, lexicographical compare three-way.
Yes.
Which
yes, thank you for that, yeah.
is exactly kind of what you want for a sequence comparison like this.
Yeah. I remember seeing that, and I didn't want to add another thing, but yeah, you're right. We don't need to do that anymore. There is something added to the standard. I just want to take a look at what you mentioned because I've done that. Okay, 1 second. Where is my? Is this one? Yeah. Okay, so this would be the lead. Okay, let's close this. Okay, so. Okay, so I want to disable this guy, and so this equal is not, for some reason, I can't remember the reason for that, but it needs equal default of this one.
Oh, it's because the spaceship's not defaulted. Is that the reason?
Yeah, I believe that if we would make it defaulted, we are all good. Yes. Yes. Because what happened when you default it, then if you look at CPP Insight.
Yeah, you see it.
You see it.
We saw it earlier. Yeah.
Yeah.
In regards to no except, right. Defaulted, I think defaulted operations are automatically no except if they can be.
Yes, I agree.
So if you were to take the no except off the left-hand side there, the insights would still show that no except was, or I don't know what the insights would show, but the compiler generated function could still be no except.
No except if there are no except, yeah. So this one is no except. And let's take a look at the other one. So this icomp. Okay, so we only have this one, but if I want to have this, the compiler would generate it for us. So this is, remove that, but where is the less than? I can't find it. Now, there might be some strange things happening with the generation because I've seen few issues, but it's interesting that this one only required this. Let's take a look at the.
Kobe, do we have a chat in this call? I can post a link.
Yeah, there is a chat. Unless guest cannot post anything. So I apologize. I don't know how it works.
The chat's not visible to guests.
I see.
I'll send you a link on WhatsApp. Maybe you can post it.
Okay, I'll do that. Okay, so it works, but I don't understand why the CPP Insight is not showing, unless I'm missing something. I'm blind. Oh, okay, here it is. And it's no except. Yeah, I don't know why the operator equal is not, but this is no except. Yeah, I was missing this. I was completely blind. Okay, we have few minutes. Have that done. So there was a LinkedIn post that became a read it. So take a look at this, like quickly. There is a struct, there is a char, there is a friend that actually has a less than, and this operator which is not explicit, okay, that returns the address of. So it's a const char pointer. We have an array. By the way, why one? Oh, there are two, actually, there are two arrays. Yeah, my bad. There are two arrays here. One is E, so it's array of one element. Another array of one element D. And we compare these two. In CPAPAS 17, we have 0. Sorry, we have 1 and we have 0 in CPAPAS 20. What happened in CPAPAS 17? So CPAPAS 17, we don't have, so std array doesn't have the three-way operator, but we do have it in 20. What happened is that in 20, the const char pointer is being used, and then it compare pointers. In 17, we don't have that, so it's pretty much going into the less than, and it's compared, and D is less than E. I think this whole thing is especially done like this because the address of would be swapped. This is why in CPAPAS 20 we see that. Now it is being fixed. I think if we have it as explicit, then I don't think this would. We can take a look quickly. So this would be 20. Execute, and it's 1. Actually, in 20 it's 1. It's pretty weird. I wonder if it's a Clang issue. Where is my Clang?
It looks like they have favorite stars on the right. You should probably favorite it.
Okay, it's 1 also on Clang. Interesting, because the whole debate was that it's 0 on C plus 20. Oh, there is a. Okay, so I don't know. So this is 0. What is the compiler that's being used here in Clear? I don't know. But I think the layout is kind of makes the difference. But by the way, if we put explicit here, we already here. It's not. Okay. Okay, this is CPAPAS 17. How do we make 20? Can I do it? Can I do it here? I can. Okay. I think it's also 1. Yeah. So explicit fixed it. Seems like. So that's what I wanted to like. The takeaway is that people kind of reporting that if you have a specific behavior, it might change between CPAPAS 17 and 20. It's not true only for this specific use case. There's other places where things might be a bit different. But that's what I had for today. Thank you for your insight and helpful comments. And two things: either you tweet, Discord, WhatsApp for all kinds of follow-ups. The TDD would happen next month. Thank you so much for sticking. Have a good night if you are on the West or East Coast or Canada and so on and so forth. It was great seeing everyone. If you are from Europe, it's like the middle of the night. I don't know what you were doing awake. Take care, everyone. It was fun seeing
Thanks,
you.
Kobe.
Thanks. Bye-bye.
Thank you, Kobe. Pleasure as always.